Welcome to my channel. Today we are going to look at the operating laws of indices. So, when we talk about indices, what we mean is numbers that are raised to certain powers. For example, we have, let's say, I'm having here 5 to the power of 10. This 5 right here is the base. And then this 10, which is a superscript, is known as the exponent. This is also referred to as index. We can also refer to it as power. So, when a number, the base, is raised to a certain power, in this case 10, when a base is raised to a power or index or exponent, then we have what is called index notation. Index notation, we also call it index form. Okay, so there are certain rules guiding operation involving index form or index notation. So we are going to look at those operating laws. First, we are going to look at the addition law. Addition law. Now, this addition law is applicable when you have two or more index numbers, or two or more numbers that have been written in index notation multiplied. For example, we have, let's say you have a raised to the power of m. Let's say I'm using real numbers now. A to the power of 5. Okay, let me use 3. A to the power of 3 multiplied by a to the power of 2, for example. This can be expanded to give a multiplied by a times a multiplied by a. This will give a multiplied by a multiplied by a multiplied by a multiplied by a. So you can see the a keeps repeating itself, and in this case we have the a repeating 5 times. So we can say a to the power of 5. Now if you look at this 5, it simply is the result of adding 3 and 2. So I can summarize the whole process by saying a to the power of 3 multiplied by a to the power of 2 will simply give me a to the power of 3 plus 2, and that gives a to the power of 5. So in general, we can summarize the results by saying a to the power of n multiplied by a to the power of n will simply give us a to the power of m plus n. So that is the addition law. The addition law, when you have the same base raised to certain powers and the two numbers are multiplied, then you simply use the addition law. So let's look at the second law. This one is called the subtraction law. So instead of, in the case of here we have multiplication, what about when we have division? A to the power of 3 divided by a to the power of 2. That will give a to the power of 3 divided by a to the power of 2. And this in turn means a times a times a all over a times times A. So A will cancel A will cancel A. So we have A to the power of 1. This one, as we can see, is the result of subtracting 2 from 3. So we can summarize to say A to the power of 3 divided by A to the power of 2 is A to the power of 3 minus 2. That gives us 1. A to the power of 1. We can therefore generalize by saying that we can generalize this result by saying that A to the power of n divided by A to the power of n is the same as A to the power of m minus n. So that is the second law of indices. Now let's go to the third law, which is known as the zero power law. Now, for the zero power law, and this can be derived from the second law. From the second law. Now, if you notice here, what about the case where we have a division and then the exponents are the same? So let's say, for example, we have A to the power of 5 divided by A to the power of 5. This simply will give me A to the power of 5 over A to the power of 5, which we know the answer is 1. And this one can also be achieved by saying A to the power of 5 divided by A to the power of 5 will give me A to the, that's by applying the second law, 5 minus 5. And that will give me A to the power of 0, which is, so that's A to the power of 0. So according to the rule, comparing these two results, by the time we compare these two results, we will notice that A to the power of 0, so we can conclude by saying that A to the power of 0 is 1. A to the power of 0 is 1. So that's for the zero power law. Next, we look at the fourth law. This fourth law is also derived from the second law. In this case, I'm going to call it as, this law is actually the negative index law. The negative index law. So, I can go back to that law 2. So, if I have, for example, A to the power of 3 divided by A to the power of 4. This will give me A to the power of 3 all over A to the power of 4, and then further I will have A times A times A divided by A times A times A times A. See, this A here is repeated 3 times, while this is multiplied 4 times. So what we are going to do now is that A will cancel A will cancel A will cancel A. So what do we have? We have 1 over A. Now, I can also achieve this by saying, that A to the power of 3 divided by A to the power of 4 will give me A to the, that's from the second law, 3 minus 4. And that means A to the power of minus 1. So what this means in essence is that A to the power of minus 1 is the same thing as A 1 over A. So the law says, the negative index law says that when you have a number, which is the base, raised to the power of a negative number, then the rule says we should take the reciprocal of the base, and then we now raise the base to a positive index. Take the reciprocal of the base, and then this index of -1 becomes positive. So that is for the negative index law. Now we're going to look at the next law, known as the fractional index law. That's law 5. Fractional index law. Fractional index law. So here the law says if you have a base to the power of a fraction, let's say 1 over n. So what happens is that the n becomes roots. The n becomes the root. The base stays under the root sign, and then this numerator of 1 becomes the power. When you have this type of case here, the rule says the n, which is the denominator of the fraction, becomes the root. So what we have is nth root of a. This can also be written as nth root of a to the power of 1. So this one can take these two positions, and both are acceptable. So that's the fractional index law. Now what about the case? This is the variation. This is the first case. What about the case where we have the fraction now? You have a denominator and then a numerator that is not 1, that is different from 1. Let's say, for example, we have a to the power of m over n. The law says it's going to be, the rule says it's going to be the nth root of the base to the power of m, which is the same thing as the nth root of the base to the power of m. So both are accepted or correct. So that's what we have there. Now, so those are the cases where you have a fraction and then you have it this way. Now, there's another variation of this where you have c, you have a negative fraction, a to the power of minus m over n. So, now, already you know from the negative index law, when you have a negative index, so it becomes a reciprocal, okay? So once you have a reciprocal, the power becomes positive. So what do we have here? So this now becomes 1 over a to the power of m over n, okay? And then you have 1 over nth root of a all to the power of m. So that's what you have. So these are variations of the fractional index law. So in the fractional index law, you have the same base hold true. In the first case, you have a fraction with a numerator of 1. In the second case, you have a fraction with a numerator that is not 1. And then, of course, you have another variation of it, which is, in this case, a negative fraction. That is an index, a fractional index that is negative. So this is what you have. Now let's look at some other laws, operating laws of indices. So we are going to look at the product of power law. Product of power law. That will give us number 6. The product of power law. So this, let's say for example we have 4 to the power of 3, then everything now to the power of 4. What do you have here? there are two ways I can approach this. First, I have 4 to the power of, okay, let me make this power 2. 4 to the power of 3 times, you know, it is a square, times 4 to the power of 3. And from the first law, this will give us 4 to the power of 3 plus 3, which is 4 to the power of 6. Don't forget that this power 6 is the product of 3 and 2. So I can also, at the same way, solve this by saying, instead of going this route, I can say 4 to the power of 3 multiplied by 2. That will give me 4 to the power of 6. Same result. And that leads us to this, to say, that if I have a to the power of n raised to power n, okay, a to the power of n, and then the whole expression is now raised to the power of n. So I'm going to have to say a to the power of m times n. That will give me a to the power of n. So that is the product of power law. The product of power law. Now let's look at number 7. Now if you take a look at what we've been doing, you will find out that we've been dealing with whole number base. What about case where you have a base to be fraction? What do I mean? I have fractional base law. Fractional base law. Now I'm going to introduce a fraction to the base. So if we have a, in this case I'm going to have a over b. Okay, a over b. So, and then fractional base, let's say the power is m, so it's going to be a raised to power m over b raised to power m. Okay, so in indices, when you have division and you have a common power, the power will distribute over division. So in indices, powers distribute over division. In the same way, if I have, this is the first part, fractional index law. If I have the fractional base law, okay, I think let me take this over here now. I have a over b to the power of m over n. So what would this be? This will give me a to the power of m over n over b to the power of m over n. And then this will give me nth root of a to the power of m over nth root of b to the power of m. Now, because we have the same roots, this is nth root of a and nth root of b. So we can as well go further to say this will be, we can take the common roots, which is nth root now, and then we have a over b all to the power of m. So the result to this is what we have here. Now let's also look at another form of that law, in which case it is another form of this. If you have a over b to the power of minus m over n. Okay, so the rule is that from what we've seen previously, when you have a negative index, the base has to become a reciprocal, okay? So what is the reciprocal of A over B? It is simply B over A. And then of course when this is done, the negative becomes positive. So you have M over N, which now becomes nth root of B over A to the power of M. Nth root of B over A to the power of M, which in the same way can be written as nth root of B over A to the power of M. So that is the law of indices right there. I think there's one more that we're going to look at. That's law 8. Okay, let me take a look at that here. Law 8. So for law 8, this is called different base law. You know, we've been looking at same base law. What about the case where you have different base? If you have A raised to power M times B raised to power M, what happens here is that you have, the law says, if you have different bases but same power, we simply multiply the base and then take a common power. So that will be AB to the power of M. AB to the power of N. Please note, we're going to put a caveat here. Please note. Okay, before I do that, let's say if you have A raised to power M divided by B raised to power M, is going to be A divided by B, okay? That is A raised to power M divided by B raised to power M, which is the same thing as A over B raised to power M, since they have the same power and it is allowed for us to take the common powers, okay? Now, I'm going to put a kind of a note that, let me put it this way, note that, how do I put it now? Note that A raised to power M plus B raised to power M is not the same thing as A plus B raised to power M. It's not the same thing. Okay? Also, note that A raised to power M minus B raised to power M is not the same thing as A minus B raised to power M. So this has to be clarified, okay, before so that when you see this kind of situation in an exam, or maybe in a practice question or in an interview, you should know that powers do not distribute over addition and subtraction. It doesn't distribute. Okay, so let's take a look at the final law, which in this case is not really a law, but a kind of thing that you need to know. Let's say number 9. Oh, sorry, I'm not supposed to use that. If A to the power of M equals to B to the power of M, then it means that A equals to B. That's for the first part. For the second part, if you have the same powers, two sides of an exponential equation, and the powers on both sides are the same, it then means that the bases are also the same. In the same vein, if you have different powers but the same base. So you have y to the power of m equal to, here we have different base, y to the power of n. Because the bases are equal, then the powers must be equal. Then m is equal to n in this case. So these are the operating laws of indices. Now, let's see how we can use these laws to solve some problems, okay? So I'm going to look at some problems now. Okay, before we look at the problem, there is one more thing that I need to correct here, and this is it. This is it here. Maybe we can make that number 10. Now, if minus, okay, it's not like a law, but I just need to make that note. Number 3, I'll see here. Also, if I'm not going to use if. Let me see. Note also that minus a to the power of m. Minus a to the power of m. So if you have a base that is negative, if you have a base that's negative, this will have two outcomes depending on whether m is even or negative. So I'm going to put it this way. Now, if m is positive, then if m is even, okay, let me put it this way. This will be equal to a raised to power m when m is even. Okay? It will be equal to a raised to power m. But if m is odd, it will be equal to minus a raised to power m if m is odd. So that is what I need to make clear. Okay? So there's no need to put there's no need to put it. Okay. So we have this. So I need to make that note. So we can now go ahead to look at some problems on some questions. So I have some questions here I want us to look at before we call it a day. So I'm going to start the question from this side. Okay, so we have simplify the following. 2,401 to the power of minus 1 over 4 b. Okay, let me put that here. Fourth root, fourth root or cube root rather, I think it's cube root of 64 divided by 1 over 125 to the power of minus 1 over 3 square bracket squared. 2 raised to the power n plus 1 times 2 raised to the power n minus 1, then bracket n plus 1 divided by 2 raised to the power n bracket n plus 1. And then lastly, I have this 16, it's 1 over 16 raised to the power minus 3 over 4 times open square bracket 25 over 9 raised to the power minus 3 over 2 divided by open bracket 5 over 2 raised to the power minus 3 close square brackets. So I'm going to come over here. I'm going to come over here. Yes. So let's look at the first question. Solution. Solution here is, the question is 2,401 to the power of minus 1 over 4. Now, what we need to do here is to express this 2,401 as a power of 4. How do we do that? I think this is going to give us, let me see, the last number is 1. That means this is an odd number. If 5 cannot work, 3 cannot work. Maybe I can look at 7. Let's say I have 7 times 7. That is 49. Multiply by 7 again. This will give me 63. 28 plus this, that's 28. That will be 34. Multiply that by 7. That will give me 21. 28 plus this, that's 30. That's 21 plus 33. That's 24. Okay, so that means this will give me 7 to the power of 4 raised to the power of minus 1 over 4. Can you see that? And then here I have 7 to the power of 4 times minus 1 over 4. 7 to the power of 4 times minus 1, that's minus 4 over 4. That's 7 to the power of minus 1, which is 1 over 7. B. Cube root of 64. Cube root of 64 divided by 1 over 125 to the power of minus 1 over 3 all squared. Now this will give me, of course we know that the cube root of 64 is 4, divided by, because this is a negative index and it is a fraction, so what we need to do is to say this becomes reciprocal, so that will be 125 over 1 to the power of 1 over 3, and that will give us, so that will give 4 divided by cube root of 125, cube root of 125, everything squared. Okay, that's 4. I think I should just move over there. Yes, so I have from here, so this will give me 4 divided by cube root of 125 is 5. Everything to the power of 2. that is 4 over 5 to the power of 2, that is 16 over 25. 16 over 25. Okay. So let's look at the next question, which is C. I'm going to repeat the whole of this. 2 raised to power n plus 1 times 2 raised to power, open bracket, n minus 1, n plus 1, divided by 2 raised to power n bracket n plus 1. So we want to simplify this and see what we get. Okay, so we start by saying this is 2 raised to power n plus 1. Okay, let me say, applying the first law of indices in reverse, we are going to have 2 raised to power n times 2 raised to power 1. Okay? Then, of course, this will give me times 2 raised to power n minus 1 times 2 raised to power n plus 1. No. It's not going to work that way. It's not going to work that way. Probably I should just say, here, I can factorize 2 raised to power n plus 1 out. Yes. 2 raised to power n plus 1 is common. And then I have 1 plus 2 raised to power n minus 1. And then close the brackets. Yes, all over 2 raised to power n brackets. So here, I can do this by saying times, this one is not going to work as well. It's not going to work. It's not going to work. Okay, let me have this back. I think I'm looking at what I can do. Okay, let me take it this way. 2 raised by n plus 1 times, let's open up this bracket. This will give me n squared plus n minus 1. Okay, that will give 2 raised to power, or all over 2 raised to power n squared plus n. Yes, so we have 2 raised to power n plus 1 times n minus n will go n squared minus 1 all over 2 raised to power n squared plus n. I think I should just come over here and continue. So from here, I can say 2 raised to power n plus 1 plus n squared minus 1 all over 2 raised to power n squared plus n. So this will give me 1 minus 1, that will give me 0. This and this will go, so you have n plus n squared over n squared plus n. So this will give 2 raised to power n plus n squared minus n squared plus n. That's using the division law of indices, and that will give us 2 raised to power n plus n squared. So once I open up this bracket, I have minus n squared minus n. And so we are going to have 2 raised to power n squared, and n squared will go, n and minus n will go. So that will give us 0. So the answer here is 1. Okay. So the answer is 1. So let's look at the last question. The last question is I hope that's D. 81 over 16 raised to power minus 3 over 4 times open square bracket 25 over 9. I hope, is this the correct question? I think it is. Yes, I think it is. So this one will just give us 2 raised to power 0 equals to 1. So we have minus 3 over 2 divided by 5 over 2 to the power of minus 3 close square. So what we need to do here now is, first we apply the reciprocal law here. The reciprocal law comes into play, so it's going to be 16 over 81 to the power of 3 over 4 times, same thing happens here, 9 over 25 raised to power 3 over 2 divided by, same thing also happens here, 2 over 5 raised to power 3. Now move over to this side of the board. So, coming over to this side of the board from here, this will simply give us fourth root of 16 over 81 raised to the power of 3 times open square brackets. This will give us square root of 9 over 25 raised to power 3 divided by 8 over 125 close square brackets. So we have here now, this will give us the fourth root of 16 is 2. Fourth root of 81 is 3 to the power of 3 times, here the square root of 9 is 3, square root of 25 is 5 to the power of 3. So what we're going to do is that I'm going to do a little bit of fraction here, board mass. So this sign changes to multiplication, 125 goes up and then 8 comes down. So we have 2 to the power of 3 is 8, 3 to the power of 3 is 27 times, you have 27 here, all over 125 times 125 all over 8. So let's deal with this. 125 goes here, and then we have 8 over 27 times 27 over 8. So this will go and this will go. So the result is 1. So we have come to the end of this class. Thank you so much for staying. Please subscribe to this channel, like my video, comment, and then share my work also to your friends and colleagues so that they can also benefit from what you have learned. So what I'm going to do is that in the description of the video, I'm going to leave a PDF file that you can download. I especially made that PDF file for you, so it contains a lot of questions on those laws that we have treated. I hope to see you in the next class. Thank you.